Hello coders, I welcome you all. As you know, in the last video, we discussed experiment tracking using MLFlow, which is a widely used tool in the industry for this purpose. We can use MLFlow in two modes that you can see over here, solo mode and remote mode. In the last video, we used MLFlow in solo mode, meaning that only we can use it and no one else can collaborate with us. Also, we can say that we used MLFlow locally, which means only we can see the experiments because the logs are stored on our personal machine. This setup is limited to solo work and does not support collaboration because we are storing logs on our local machine, which is of no use for collaboration. But in the industry, many people work on the same project, right? So we need to collaborate with them to ensure they can see our experiments and we can see their experiments. So that's why we required remote mode. And to collaborate with others, we need a remote tracking server. This allows team members to access and share experiments log in a central cloud-based location. Please remember, if we want to collaborate with others, we have to set up a remote tracking server. So now let's first start with what is MLFlow that you can see over here. MLFlow is a tool for logging and querying experiments. We can record parameters, metrics, and artifacts. Artifacts like models, data, etc. for our machine learning experiments. So now let's understand what is MLFlow tracking that you can see over here. MLFlow tracking. Tracking server is a service where these experiments are logged. Please remember, by default MLFlow logs locally, but we can set up a remote server to store and manage logs from anywhere. I hope all of you are clear with MLFlow and MLFlow tracking. So in this video, we will create a remote tracking server of MLFlow that will be available on the cloud, allowing team members to collaborate and view each other's experiments. There are many ways to set up a remote tracking server for MLFlow. So for that, we can use AWS, GCP, and other platforms. However, in this video, we are going to set up the remote tracking server for MLFlow on DexHub. So now let's first understand what is DexHub. As you can see here, DexHub is a platform built for versioning and collaboration in data science projects. It integrates with Git and DVC, providing a user-friendly interface for managing ML projects that you can see over here. So now let's move on. The question is, why use DexHub as a tracking server? As you can see over here, remote tracking server. DexHub can act as our MLFlow tracking server, allowing us to log experiments from any environment to a remote shared location. That's why we are going to use DexHub as a remote tracking server for MLFlow. Now let's move on. So you can see, using a remote tracking server for MLFlow offers several key benefits that you can see over here. First benefit, centralized tracking. All experiments and artifacts are stored in one place, making it easier to compare and reproduce results. Second benefit, collaboration. Team members can access and contribute to the same experiment logs and artifacts. Third, version control. DexHub integrates with Git, so we can track code, data, and model versions together. So these are some of the key benefits of using DexHub as a tracking server for MLFlow. So now let's take one example scenario for better understanding that you can see over here. Imagine you and your team are working on a machine learning project. Instead of each member logging their experiments on their local machines, everyone logs to the DexHub tracking server. This allows the entire team to see and analyze each other's results in real time, ensuring better collaboration and efficiency. Hope you can understand. So let's move on to the practical part. As we discussed in this video, we are going to set up the remote tracking server for MLFlow on DexHub. So for that, we are going to perform the following steps. So let's start with our first step, logging into DexHub. This one, logging into DexHub. So let's complete our first step. You can see currently I am on dexhub.com, website of Dexhub. So let's first log in into Dexhub. So let's press this particular button, login. You can see we can log in to Dexhub using GitHub, Google, and also we can create new account. But I will be logging with GitHub. So let me click this particular button, continue with GitHub. You can see over here, we have successfully logged in to Dexhub using GitHub, that you can see over here. After successful login, you can see this particular page. So as per our flow, we have completed our first step, logging into Dexhub. Now let's move on to our second step, create a new GitHub repository. So now let's create a new GitHub repository. Now let's move to GitHub. So you can see currently I am on github.com and inside my GitHub account, let's click on this particular tab, repositories, and let's click over here, new. And here we have to give name of our repository. Let me give MLFlow _exp _dexhub. You can give any. Also you can give description, but it is optional. And we are keeping this repository as public. Now done. Let's press this particular button, create repository. So you can see we have successfully created a new repository. Now let's open command prompt and let's move to the drive. Here I am going to clone the repository that just we have created. So for that we have to write following command, git clone and this link, this for our git repository that just we have created. Let's copy this link. So we can copy this particular link by pressing this button. Let's move to command prompt. Let's paste it over here. Let's press enter. Now done. You can see here warning, you appear to have cloned an empty repository. Yes, we are doing this. Let's move inside this particular folder, this one, and let's open VS Code from here. You can see over here. So now let's move on. Let's copy and paste the code we updated in the last video here. So you can see here, I am taking this particular code that we have updated in the last video. Let's copy this code. Let's move over here. Let's create new file, water_train.py. You can give any other name as well. Let's paste code over here. Let's save our file. So you can see our code. So as you can see here, we have logged metrics such as accuracy, precision, recall, and F1 score, right? That we have performed in the last video. Also, we have logged this particular parameter of gradient boosting classifier and estimators. Also, we have logged confusion metrics that you can see over here. Also, we have logged model, and here we are logging code. Additionally, we have added tags for searching that you can see over here. We have added 2 tags for searching, which we covered in the last video, right? So now you can see as per our steps, we have completed first 2 steps, logging into Dexhub, and we have created a new Git repository. Now let's move on to our third step, push our code to GitHub. Let's complete this particular step. So please remember, currently we are at our third step, push our code to GitHub. So for that, let's click over here, terminal, and let's create new terminal. You can see here. Let's check Git status. You can see here, untracked files, because just we have copied and paste this particular code over here from our last session. So now let's write git add dot to add this particular file into staging area. And let's perform commit, initial commit. Let's clear this and let's push our code. Git push origin main. Now done. Let's move to GitHub and let's reload this particular page. You can see over here. Now our code is available inside our repository, GitHub repository that you can see over here. So you can see we have successfully completed our 3 steps. Logging into DexHub, we have also created a new GitHub repository, and also just we have pushed our code to GitHub. Now let's move on to our 4th step. Connect the GitHub repository with DexHub. So let's complete this particular step, our 4th step, and let's move to DexHub. So as you can see, currently I am on dexhub.com, and currently we are performing our 4th step, connect the GitHub repository with DexHub. So for that, you can see this particular button, create. Let's click on this particular button, create. And here, then after we have to press this particular button, new repository. You can see here, we have 3 options. Create blank repository, create from template, and connect a repository. Since we have a repository that just we have created on GitHub that you can see over here with this particular name. So let's press connect a repository because we are having a repository that just we have created on GitHub. So let's press this particular button, connect a repository. You can see again 2 options. We can connect from GitHub. Also you can see here, we can connect with Bitbucket, GitLab, and others. Since we have created the repository on GitHub, let's connect using GitHub. So I'm going to press this particular button, connect. As you can see, GitHub is confirming access. So here we have to give our password of GitHub. Let me give my password and let's press this particular button, confirm. You can see, done. Now let's move on. You can see repository access. All repositories or only selected repositories. We are going to use this particular option, only select repositories. And here you can see we have to press this button. You can see we have created repository on GitHub with this particular name, MLFlow_exp_DexHub. Let's click on this. You can see my previously connected repository. Let me remove this. You can see currently we have created repository with this name, MLFlow_exp_DexHub that we have connected over here. Let's press this particular button, save. Now let's select this repository and here now we have to press connect repository. You can see this particular pop-up. Use AI to generate an image for your project. Currently, we not require this. So let's press no, thank you. So now you can see we have successfully completed our 4th step that you can see over here. Connect the Git repository with DexHub. So we have successfully completed our 4th step. Shortly, we will move to our next step, 5th step. Set tracking URI. So you can see that the interface of DexHub, and which is very similar to GitHub that you can see over here. But DexHub is used in the data science. So you can see these steps like file, datasets, experiments, models, collaborations, and annotations that you can see over here. But in this video, we are going to focus on this particular tab, experiments. So now let's move over here and you can see this particular button, remote. So let's click on this particular button, remote. And here again 3 options, code, data, and experiments. So as we discussed in this video, we are going to focus on experiment tracking. So we are interested in experiments. And you can see here, MLFlow tracking remote, which is required in our next step. And you can see code for remote tracking. So let me copy this link because we have to keep aside this information in proper file because shortly we will require this information to connect the remote tracking server. So let's copy this and let's open Notepad and let's paste it over here. Also let me copy this code and let's paste it over here. So this information will help us to connect to the remote tracking server, which is available on DexUp. So now we can say we have successfully completed our fourth step that you can see over here. Connect the Git repository with DexUp. In short, we have completed 4 steps. Logging into DexUp. Also, we have created a new GitHub repository. Also, we have pushed our code to GitHub. And just we connect the GitHub repository with DexUp. Now, let's move on to our 5th step. Set tracking URI. So in your ML code, set the tracking URI to point to your DexUp repository's MLFlow endpoint. Let me show you this. Let's move to VS Code to set tracking URI. So as you know, this is our code. So actually, first we have to install MLFlow. Using this particular command, pip install MLFlow. Let's press enter. But as you can see, in my case, requirements are already satisfied because I have already installed MLFlow on my system. Let's clear this. And also we have to install DexUp using this particular command, pip install DexUp. Let's press enter. Again, you can see in my case, requirements are already satisfied because I have already installed DexUp on my machine that you can see over here. So now we need to add the following code to our project that we have taken from DexUp. So now let's first import DexUp. Let's copy this and let's paste it over here. And also this particular code, DexUp.init. Let's copy this and let's paste it over here. Let's save our code. And now our main part. You can see set tracking URI is currently pointing to this particular location, our local host. So that we have to change with remote tracking, this one. So let's copy this and let's paste it over here. Let's save our file. I think all done. No need to change any other code. Again, let's save our file. Let's clear this. Again, first, let's check Git status. You can see this particular file is modified because we have added these many lines to our code. Let's write following command, git add dot. Let's perform commit. Added code related to DexUp. Let's press enter. Also, let's push our code. Git push origin main. Let's press enter. I think done. Let's clear this and let's check on GitHub. Let's reload it once. Let's click on our code and you can see updated code. Means all done. So now we can say that we have successfully completed our 5th step. Set tracking URI. Now let's move on to our next step. 6th step. Log experiments. You can see here, run your experiments as usual and MLFlow will log everything remotely to DexUp. Let me show you this. Let's move to VS Code to complete our 6th step. This particular step, log experiments. So you can see our code is ready because in the last video, you can see we have logged metrics, accuracy, precision, recall, F1 score using MLFlow. Also this particular parameter of gradient boosting classifier and underscore estimators. Also we have logged confusion matrix. This particular model, gradient boosting classifier. Also we have logged code file and also we have set to text for searching. Means our code is ready. So just we have to run our code using this particular command python and our file name that just we have created water_train.py. Let's press enter. So please remember in my case it not ask for authentication, but if you are running for the first time it will ask for the authentication and you have to press accept button. Then only you can run and log your experiments to DexUp. You can see that we have successfully run our first experiment and it's first run. Let's check on DexUp. Let's reload our text hub. You can see one over here. Let's click on this particular tab, experiments. So here we can say that we have successfully completed our sixth step, log experiments, that you can see over here. Now let's move on to our seventh step, view results. So as you know, now our MLFlow tracking server is available on desktop. So for that, we have to click over here, go to MLFlow UI from desktop. So let's click this particular button, go to MLFlow UI. You can see over here. It looks exactly same as we have seen in our last video in our local machine. And this is run name, which is generated by MLFlow. Let's click on this run. You can see over here. Details about our experiment. Created at, created by, status is finished. And you can see run ID. Duration of this particular run. Text that we have added, GB and data thinkers. You can see over here. Source file. And you can see current value of n estimators, which set to 500. And you can see over here metric, precision, F1 score, accuracy and recall. Let's click on model metrics that you can see over here. Let's click on artifacts. You can see over here ML model, conda.yaml, model.pkl. By clicking on this button, you can download artifacts that you can see over here. Our requirements.txt generated by MLFlow. You can see confusion matrix. And also we have logged our code as well that you can see over here. And you can see currently MLFlow is running from our desktop that you can see over here. So we have opened this MLFlow GUI that you can see over here from desktop that you can see over here. By clicking on this particular button, go to MLFlow UI, we can open MLFlow from desktop that you can see over here. Now, as you can see, we have completed our seventh step as well that you can see over here. Now, let's move on. I want to show you one thing. As you can see, our remote tracking server is now ready. Anyone can collaborate using this. Let me show you how someone can collaborate using this. Currently, assume that your one of the team members is doing all these things. So first, let's move to our GitHub repository, this one. And your team member has to clone this particular repository. So let's click on this and let's move to C drive. You can see currently I'm using a different location because currently we are treating ourselves as a team member. Let's perform git clone and let's paste that particular link over here. Let's press enter. Now done. Let's move to MLFlow _exp desktop. Let's press enter and let's open VS Code from here. You can see over here. So this way our team members can collaborate and this is our code that you can see. So as we discussed, these steps are being performed by one of our team members. If they want to perform another experiment, they will create a new Python file. So let's create new Python file. Name water_exp_rf.file. Select this code. Let's copy this code and let's paste this code over here in newly created Python file. Let's save our code. Now let's perform some changes. First, we are changing experiment name. Let's change to RF. Let's save this file. And here in place of gradient boosting classifier, we have to use random forest classifier. Let's save our file. Here also random forest classifier. Also we want to use another parameter max underscore depth to 10. So here we have to add this particular parameter max underscore depth that we have set to 10. So please remember these steps are being performed by one of our team members, right? Also don't forget to log our newly added parameter max underscore depth. Let's save our file. Also we have to log random forest classifier in place of gradient boosting classifier. Let's save our file. In place of this author, let's provide our team member name, Anil, and model RF. Let's save our file. Now let's open terminal and let's execute our newly created Python file, which is created by one of our team members, water_exp_rf.py, this one. Let's press enter. You can see all done. We have successfully executed our code that you can see over here. Now let's move to DexUp and our MLFlow GUI, which is running from DexUp from here. And you can see our second experiment generated by our team member that you can see over here. Let's click on this. You can see details, you can see text, RF, author Anil, and you can see currently 2 parameters logged over here, nestimators and max_depth. And you can see metrics, F1 score, accuracy, precision, and recall. You can see model metrics and artifacts that you can see over here. Confusion metrics and code. You can see water_exp_rf. These steps are being performed by one of our team members. You can see over here our 2 parameters and random forest classifier that you can see over here. You can see that we have successfully created a central tracking server of MLFlow using DexUp that you can see over here, which allows us to collaborate with the team for experiment tracking that you can see over here. We have created this particular experiment, and this particular experiment being created by one of our team members that you can see over here. So you can see this way team members can collaborate with each other, can see our experiments, and we can see their experiments that you can see over here. I hope all of you are clear with this. This is how we can set up a remote tracking server for MLFlow using DexUp. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.